Okay, Cap, we're back. We're trying to find points of interest. That is our goal. And the first thing I want you to do is look at the domain and see what that tells you. And in an example, you'll see why that's important. Then I want you to find the first and second derivative. And we're going to set the second derivative equal to 0. Now we haven't had to do that. We've used the second derivative, but we haven't set it equal to 0. So now we are going to set it equal to 0. And we're going to find, so this is my f double prime line, points of inflection. Possible points of inflection. So say the second derivative is 0 here at 0, and maybe it's 0 here at 2. So I'm just making one up. And then you do have to test to the left and right. So here maybe I'll test -1, and I actually throw that into, so test to the right and left of points where the second derivative equals 0. All right, so say I test over here and we get -1 and we find that it's, it's positive. And then here we say we test 1. And putting it into the second derivative, we see that it is negative. So now, if it goes from positive to negative, then we know we have a point of inflection. And now suppose at this point it goes from negative, and say we test 3, and we get a positive. It went from negative in this interval to positive in this interval. And the second derivative changes from positive to negative and negative to positive, indicate that these points are points of inflection. So points of inflection occurred at x equals 0 and x equals 2. All right, it's always clear when we use a real example. So I'm going to ask you to do this for me. Let's play a game. I'll say, I do, you do, I do. So here's I do. So what I want to do, and this is example, and please write it down, is find where concavity is upwards or downwards. So find concavity and points of inflection. POI. All right, so here's the function that we're going to work this magic on. All right, so we're going to take this function, and as I said up here, we have to find the first and second derivatives. Oh yeah, look at the domain. So for the domain, it's going to be, the domain is an element of the reals. This is a polynomial. Polynomials are smooth curves with no sharp turns, skips, or hops, or jumps. They have real coefficients, and their exponents are integers. So therefore, we have a polynomial, and they have no points in the domain which have to be restricted. So the domain is a set of all reals. So that's not very remarkable, but do get used to looking at the domain. All right, next we will look at the first derivative. And according to our plan up here, after we find the first and second derivative, we set the second derivative equal to 0 and solve that. All right. I think I made a boo here. So this is supposed to be a 6. So that would make this a 6. And inside here, I'd have an x minus a 2. All right. Hopefully you caught that before I did that. And I think is there another boo-boo? All right, right here, when I took the derivative, let me just start this over. All right, don't have my pencil with me, you can tell. That's why we work in pencil. All right, so take the first derivative, and I'm going to get 3x squared minus 12x minus 3. All right, that's correct. And then the second derivative is 6x minus 12. All right, that's what I was trying to get. Now I can set that equal to 0 and factor it. And when I set each factor equal to 0, I get x equals 2. So that tells me that in my little sketch, it's my second derivative at x equals 2. That's where it zeroes out. So this is a possible candidate for a point of inflection if the concavity changes from left positive to negative or negative to positive. So we'll test a point and see. So I'm going to test 0. And when I put 0 in, I put it into the second derivative. So when I do that, I get negative 12, which is negative. All right, and then I'm over here, I can test, how about 1 million? No, I'll test 3. But 1 million would be fine. Anything greater than 2. So I picked 3, and that gives me a 6. And that is a positive number. So what can I conclude now? Because the concavity went from negative to positive, there was a change in concavity across this value for x. We can now say that the point of inflection is 2, and now I just need the y coordinate. I need both x and y. So to find the y coordinate, I go way up to the beginning of the problem where I've had f of x, and I plug in the 2. So I'm going to get 2 cubed minus 6 times 2 squared minus 3 times 2 plus 1. And when I did all that earlier, I came out with a minus 21. If you would validate that for me, I'd appreciate it. So that is the point of inflection. This function on this interval from negative infinity to 2, we have concave down. And on this interval, we have concave up. So there I have established what I started out to, find the concavity and the point of inflection. Alright, so as I said, we were playing the game I do, you do. So I'll go ahead and give you the you do. Alright, here's the you do, and you can bring that to class. And the you do is g of t equals t squared. Where'd it go? G of t equals t squared plus 1 over t. And the directions are the same. I want you to find the intervals of concavity and find any POI, points of inflection. All right, same directions. Notice, though, I will give you a heads up. When I asked you to look at the domain, this one, you'll see that we will have to restrict the domain because what's one value that cannot be allowed in g of t? T cannot equal 0. So that means when I go to do the first derivative and the second derivative, I have to include on my test line this 1.0. So you'll find other points where the second derivative zeroes out. I think you should find one other point. So say it's on this side somewhere. So that means when you do your test intervals, you'll test the second derivative in here, and then you'll test it in here, and you will use this does not exist point as well and test it over here. So you're looking for points of inflection. However, because it does not exist here, the second derivative does not exist. Remember, I'm saying we found the second derivative. That means since we're looking for concavity, you'll test these intervals for concavity, but this will not be a point of inflection. All right, so I'll just give you a heads up on that. So use the domain in that way and see what you come up with. And now I'll finish with one. And the one I'm going to do is h of x equals 3x to the fourth minus 9x plus 17. So I'm going to take that one and same directions, find concavity and points of inflection. So first derivative, 12x cubed minus 9. Second derivative is 36x squared, and setting that equal to 0, I get x equals 0. It's the only value that would cause that to equal 0. So I'm going to draw my little map, f double prime, and I'm going to put 0 here. It's a possible point of inflection. So I'm going to test -1, and I'm going to test +1. And I do that by putting it in the second derivative. So when I put -1 into this expression right here, -1 squared is +1 times 36 gives me a positive. When I put in 1, I also get a positive. So that tells me something. It tells me that this is not a point of inflection. In fact, this particular graph has no POI, no point of inflection. Because remember, for it to be a point of inflection, the graph has to go from positive to negative or negative to positive as far as the second derivative is concerned. So where are the intervals of concavity? Well, it's concave up from -infinity to 0, and then it's concave up from 0 to +infinity. Notice I couldn't include 0 because I know the second derivative at that point is 0. But it's not a point of inflection. So I usually tie these two expressions together with this symbol. So that means this or this. But I cannot include 0. And usually x to the fourth has some sort of shape that looks like this, sort of flattened out here. So you're going to get a second derivative that's 0, but the concavity is going to be positive on both sides. All right, that should be good for tonight. So you go to bed chewing on this, wake up, dream about it, and wake up and chew on it some more, and bring in all that chewing to class tomorrow, and we'll put it down on paper. All right, and bring that one example that I assigned to you, and we'll see how far you got. Till then, good night.